There was one question. There were a few questions, rather, but the earliest one came from Renato L, and I think we can answer this in just like a minute or two, which is, well, there's two. One is I'll read them both. If I don't know my DB yet, as we may not in the beginning, it's a big commitment to a project to approach a DB for a long-term relationship. Should I start with TypeScript types instead of schemas? I understand schemas handle encoding and decoding, but how do you handle multiple decoding and encoding targets, different DB formats, decoding to JSON? Yeah, that's a good question. Do you have any big thoughts on this one, Max? There's a follow-up, but that's sort of the first part. So basically, it's kind of two sides. Like, do you start with? He's not sure if he should start with schemas because it sounds like maybe. How do you deal with schemas when targeting a DB, and especially if you don't know what your final target's going to be? Are schemas adaptable, or should you wait until you know exactly what you're doing?
I don't know. I think everybody has a little bit of a different approach to this. I don't think there's a right way to do it. I'm trying to find Renato L's question in the thread, and I can't.
I linked to it at the top. He did a pre-thread days.
Yeah. If I don't know my DB yet, should I start with TypeScript types instead of schemas? I understand schemas. Yeah, I mean, I feel like when you're just starting out, TypeScript types are probably fine, and then you could figure out if you need the serialization and deserialization. On the same token, though, I feel like if you are doing anything that's going across the wire, if you're connecting to a database, you're obviously going across some serialization boundary. Then at that point, like, you're going to need something like schema anyways, unless you're just posting JSON around, I guess. But even then, like, schema is beneficial. So, like, you could start with TypeScript types just to, like, prototype something. But I feel like almost always you're going to end up rewriting those to schemas anyways. Just because, like, you're probably going to need what schema provides, especially if you're talking to an external service. And how do I handle multiple decoding targets? You just create different encoder and decoders for the schemas, and then compose your schemas with them. So, like, when you create a schema, it knows nothing about what eventual format you're going to use on the wire. Like, the V3 schema is designed to work primarily with JSON, just like V4. But in both V3 and V4, you can create different, like, encoders and decoders for those schemas and then just compose them together. So you could have, like, a user schema that you then compose with you could use schema.parse JSON to get it to be, like, JSON in the encoded position of the schema. Or you could develop your own encoder, like a protobuf encoder or a, I don't know, XML encoder or whatever. And do it that way. I think for prototyping, like, just using types maybe is fine, but, like, I think in many circumstances, if you're going across the wire, you're going to need schemas anyways. So I tend to just start with schema. But that's just me.
No, that makes sense. I've made a note to maybe one of these sessions we can do a deep dive on schema and really look at some code examples that we prepare. I'll prepare ahead of time and go into it more deeply. There was a part two to this question. Oh, sorry.
Yeah, I was going to say the other part of this question, what's the recommended way to start building without a database decision? Create a mock DB or just mock this? Yeah, I think, like, Kit did a wonderful job of showing how you can build it, like, with effect. You can code against an interface, right? So you could just develop, like, a service that exposes methods that you think you might need eventually, or you progressively build up a service with the methods that you need, and then later on, when you actually want to plug a database in, you can just create a separate service for the database and then have an implementation of the service you were building that relies on your database. So, like, yeah, I mean, if you don't know what database you're going to be using up front, that's one way to do it. The other way is to leverage Effect SQL, which, like, if you know you're going to be using a SQL-esque, like a relational database, You could use Effect SQL, which does not impose a particular DB engine on you up front. So you could like write your SQL and everything like that without worrying about which database you're going to use, and then leverage the different like database packages that we have to plug in a database later. But yeah, I mean, like, it's hard to give a concrete answer to this question because it's very it's very like the eternal software developer, software engineering response of it depends is like very applicable here. And it sort of depends in this case on like what you're doing. And you have the nice thing about Effect is it gives you a lot of different ways to go about doing this. On the same token, that double-edged sword, maybe having too many ways to maybe being too flexible ends up like confusing folks. But I think there are in my mind, the answer to this question, there's like two main routes I would go. One is like, if I don't know I'm going to need SQL, I would just build up a service with methods that I need and then figure out what dependencies that service might need later. If I knew I need SQL, I'd probably just use Effect SQL and plug in the database I end up using like later. But for prototyping, like, I wouldn't even care about what database I'm using. What do you think, Kit?
Yeah, I totally agree. If it's very early prototyping, just make a service that operates at the level of the domain type or whatever, your to-do service, and store everything in an in-memory map. I think I did show off an example of that last time. And when you're ready, you can swap that out with a different implementation that hits the database. You might need to change some things around depending on like if your ID type needs to become a string or an int, depending if it's, monotonic or a UUID situation. But it'll get you far enough and it'll make it easier enough to just minimize the changes you have to make later. And yeah, in terms of using schema for everything, I like using schema for everything. I come from the land of Scala and other functional languages that have better sort of default algebraic data types, better data type support. And schema, I kind of treat schema like a replacement for algebraic data type constructors in TypeScript. And this is kind of a better default instead of making interfaces, because it gives you an interface anyway, especially if you use the schema.class constructor, and it can be tagged and all that. It's just sort of, what I do by default now.
Yeah.
Oh,
I
yeah.
think that it's a good strategy. But like, I think you have a lot of flexibility with Effect because of the dependency injection system that we've built in. Like, I think you can sort of defer a lot of decisions till later. You can, like, people, I don't know, the more experienced you get with Effect, the more like practice you get with it. I feel like I've heard from a lot of folks that prototyping becomes much faster because you don't need to know everything up front. You don't need to make a lot of decisions up front about how your application is going to run. You can sort of like defer a lot of things till later. Like, oh, what database am I going to use? Well, you don't really need to care. Or, a lot of decisions can be deferred till later when you're starting a project. Let me see. There's a bunch of stuff coming in.
Sam asked a follow-up question to that maybe we should just get to, which is sort of related to this, which is why I think it's a shorter one too. Why do you think dependency injection isn't more common in JST as it is in Java? Which is a good question.
I feel like Mike, I wish Mike was in the call right now because I know he has a lot of opinions on this. I don't know. I think my opinion on this is that a lot of other dependency injection frameworks just either aren't as flexible or aren't as type safe or perform too much magic to be widely adopted. I think some other frameworks like get pretty close to being like really nice to use. Like I think it's Nest.js or Nuxt. I forget which one. Maybe both. I don't know. Some of the Nest. I feel like some of these frameworks get pretty close. But I don't think that. I think that a lot of these other DI frameworks perform too much magic you might say like effect looks like magic, but in reality, it's not. We're not doing anything crazy. You're just either providing like you're providing services or you're not. With these other frameworks, I think there's like a lot of other decorator-esque stuff that happens, and I don't know. It's not quite as type safe, so I think that's probably some of the reasons. But I know, I think Mike has talked about this on Twitter maybe or somewhere else before, but that's kind of like my feeling of why I think that DI hasn't become more popular.
Yeah, to do dependency injection, you need you need you kind of need a framework, or you need an effect system. Because to do it at a higher level, like in Java, there's this Google library called Juice. It starts with a G, and
Juice.
it's pretty awkward, and it's very unpleasant to use because you don't get any errors until you actually run your application, and the error messages are traditionally pretty awful. But that's kind of the sorts of things that people use. In these other languages, there also tend to be large frameworks like Play or, oh God, what else is there? Play is kind of the big Scala Java one. Spring Boot, obviously, sorry. And that's kind of all built into it. Yeah, it's extremely unpleasant. Um, but you kind of need something that controls the world, that controls your whole application, and sort of at the entry point, it needs to wire everything up correctly. So you sort of need a big authoritarian system, a big framework sort of king to make sure everything works along the lines. Yeah, it needs to force everyone into a particular pattern. Now with effect systems, because effects are blueprints and not evaluated until you run them, you sort of get that ability to propagate dependencies down. You sort of get that global control without the framework side of things, without sort of requiring people to structure their code in a certain way. Of course, they have to use effects, which does actually have a pretty large impact on the shape of your code, but it's not like it's more of a library and a set of tools than it is a traditional framework. Like, it's not like Rails, which says, hey, you have to have this folder structure, or DHH is going to come to your house with a tire iron and put you to sleep, or your app will blow up. So yeah, I think JavaScript just has a culture of kind of being composed out of small utility libraries, and I don't really know why that is culturally, except just the fact that it's a strange path dependent reason, I suppose. Maybe the fact that it kind of has just been evolving and is constantly torn asunder and dying, and there's so much competition and so many users and so many opportunities to innovate that like it's just easier for a new library to innovate in a small way. And there's less, like, Rails was able to, I don't know, dominate early because it was a smaller ecosystem and everyone kind of agreed on it early. And for some reason in JavaScript, you're built out of these little pieces, and something built out of 27 different libraries isn't amenable to being sort of wrapped in some totalizing framework, except for these libraries like Nest or Sails or whatever that do that. But that's just one of the thousands of ways of composing of the combinatoric explosion of JavaScript libraries.
Well, I think you bring up a good point, Kid, too, which is also that, like, I think DI that probably hasn't gotten super popular outside of some specific frameworks. One, because like the framework is required, but also um, because the user experience just hasn't been there for a lot of these libraries. And as we know, like JS and TS devs are very sensitive to UX. I'll put it that way. And I think it's a good thing. Like, I think like that's why the JS/TS ecosystem has grown so uh, much and in such a like user-centric direction, because like the developers in the community are very focused on like optimizing for like trying to make the user experience good. I think Effect has like a pretty good UX when it comes to DI. It's like flexible enough that you can do what you want. It's not like crazy where you need to have all these like decorators and all this other weird stuff in your code. There are some like weird patterns that you need to like adapt to, but once you learn those few patterns, like you pretty much know how to write the code with Effect. So I don't know.
That being said, it is
But
probably like it requires the most intellectual lift and training lift
for
to get
sure.
started with it. But I think that's something we need to work on and teach better. But yeah, I mean, there's a set of foundational fundamental ideas that exist. These composable ideas that exist throughout effect, and layer is kind of an extension of them. DI is an extension of them. It's not some so we brief tangent, but the reason I sort of got interested in functional programming in the first place, like I started with Ruby on Rails, which very much was do things this way, don't question it, put name your files correctly and put them in the right folders, and everything's going to work out for you. And it doesn't really give you, as a new developer, you don't get to see the innards. Like you can get an HTTP server working and not really fully understand how HTTP servers work, which is really nice to get started. But there's something about if you want to learn a lot of things, and you keep learning new libraries, APIs designed in that frameworky kind of way, they're sort of arbitrary. They don't teach you anything about the world. It's just like, no. That's why I hate config. That's why I hate DevOps so much. It's like you got to put the right values in the YAML in the right order. There's no sort of deeper theoretical framework at play here. You just have to make sure the right things are in the right places in the configs and just keep iterating. And there's a 10 whatever minute iteration loop cycle because you got to push it to prod or whatever. And you learn nothing.
And
And
you
every
don't
time,
like YAML?
I know,
What?
I know. It's crazy. I'm being pretty controversial here, but so you learn one API for doing whatever caching in Rails or something, and then you want to switch to another one. It's like a completely different API and set of ideas. There's nothing unifying it. And what was so tempting about functional programming for me at the beginning was that it figured out sort of these really big, meaty prime factors of programming that at least this was promised. So you can sort of it sort of unified a view on everything. Everything became a function. A server is a function. Whatever. Your programs are all composed of functions, and therefore you can sort of get more bang for your buck learning wise. That doesn't always end up being the case. Anyway, I forget what I'm saying. So we could take a caller because we got a caller. Benjamin.
Benjamin, welcome.
Hello, Benjamin. How are your stacks of books doing? Are they growing? Are you trimming them?
Are you trimming them?
So I have to read most of them. So
Have you watered them recently?
So I've got a question. So I did a deep dive into, and I believe Maxwell, you're the one that created the AI tool and AI toolkit modules, correct?
It was a hybrid of me and Tim. Tim did
So-
like the first pass on it, and then I did a second pass.
I think that the pattern there is like God tier, and I sort of yoinked and bastardized it in my repo, and I renamed it Contract and Contract Kit. And so I really just like the pattern of like doing like the AI toolkit .of and then providing the implementation, just like very clean separation of domain and implementation. And I've sort of been like using it in a way with Effect Atom, and I like it because I can do the AI toolkit .of, but I'm not sure that validates the like payload and the failure schema and the success schema in the same way that, providing it as like a 2-layer. Does that sort of make sense? I'm more asking, how would one say create either a method on like AI tool to like provide a one-off implementation? Could you do like your contract.implement or something like that? And I know that you're doing validation of the different channels in some of the methods of AI toolkit, but it's like an object that validates that each of the contracts given to the contract kit are provided an implementation. And I'm wondering
Are you asking how to implement the individual tools, like without making them into a toolkit, or?
Yeah, something like that. And then also sort of like how, because I've tried using I think 2 context and 2 layer, and those work obviously in the AI tool scenario where it sort of like uses this map to get the implementation at runtime in the background, but I'm like, how would one like lift that implementation into, say, like an effect service? And then how might one like, because I can use the contract kit.of or the result of contract kit.of to do like whatever, or my kit dot my function, and then I can like give that to Atom.function. I can just do like contract kit.my function. And now
Maybe
I have
so the pattern that I had adapted into AI Toolkit evolved out of Tim's original work on RPC. So Effect RPC has like a very similar define your spec first and then implement the spec later, and that gets built into like a layer type of thing. It's kind of the same thing we were talking about last week with RJ. So you might want to have a look at RPC, because I believe that RPC groups have the ability to define handlers for individual RPC methods. I think. And I think there's a test for it too, I think. I might be making this up, but I'm pretty sure that exists. I'd have to like, get my hands dirty with like contract kit and whatever to like really know what you're trying to achieve. But I think
I basically just
like,
I just renamed some things from AI Toolkit. Like I basically copied, pasted AI Toolkit, renamed AI Toolkit to contract kit, and then AI Tool to contract. And I'm making use of the .of to then like give it to Atom functions basically. And I like it because it's a really like clean way to define your like contracts for your different service methods. And basically, I don't know if you've like taken a look at Lucas Barake's tutorial series, but he sort of makes this HTTP API abstraction where he can provide a handler to his endpoint schema. Well, it's a collection of schemas. It's like a failure schema, payload schema, success schema. And I struggle with the like how might one create an abstraction such that you can do that validation, because in the source code I'm seeing that like the dot of, which like basically gives you the types that, or like you can provide the implementation, but I don't believe it validates the like success. Like it's not a higher order function that validates the.
I did. So the thing I prepared a little bit of, though it's kind of a messy preparation. It'll be a messy demo if we do go into it. It is kind of an implementation of a basic version of the RPC abstraction from scratch, and that might answer some of your broader questions. I'm not sure. Maybe that could be worth going
basically
through.
it's like if one's providing a payload schema, success schema, and a failure schema, how do you validate all of those? The input, the failure, and then the output.
Yeah. Let's
so that you can like create like an interface for which you can implement.
So just to be clear, when you create a tool, for example, an AI tool, that's your spec for the tool, but you're not actually implementing anything, right? You're asking if you do tool, you want to create a handler implementation for a tool, like an individual tool. I'm still not fully clear on what you mean.
Sort of like because in an AI toolkit you have the two-layer method, and here you like use schema cache.get, you get those schemas, and then you decode the payload, like you're sort of like wrapping the effect that's provided as the implementation in the two-layer method.
Yeah, when you
contract,
when you pass a toolkit into a AI generation method or anything like that, at some point with any of these like spec first frameworks like RPC or AI toolkit, at some point you need to take your spec and turn it into the handlers for your thing. With RPC, you do that when you do two-layer on an RPC, which like. Is it possible to show some code around what's being spoken about here? I'm a little lost. Yeah, let me maybe show something. Let me move my screens around. I can pull up some concrete stuff, unless Kit had something prepared.
I do have a little demo, but it might be a little while before we get to that portion of it. It's a couple of steps away in this from scratch approach.
Let me just open up
I do have permission to share my screen as well.
Well, before we get to like any actual like concrete code from anybody else, just want to like clarify a few things for the listeners, and then we can like talk about that. I'm going to use RPC as an example, and I'm going to share my screen. Share screen. Entire screen. This one. Can you see my browser window?
Yes.
Yes, it's very, very tiny, but other than that, yes.
So
maybe one more ambiguification.
So like what we're talking about here is basically like frameworks that we have built into libraries that we have built into effect that allow you to define the specification for a particular API that you're going to expose before you actually like implement said API. So like RPC is a good example of this, where when you create a group of RPCs that you're going to expose from potentially like an RPC server or you're going to access via an RPC client, you create like a group of them. And these RPCs don't know anything about the actual implementation that they're eventually going to be associated with. They're literally just a group of RPC specs. And so when you create an RPC like this, you're saying, okay, this is a user list RPC. That's the name of the RPC. If it succeeds, it's going to return a user. In this case, we're not specifying an error, so it's never going to fail, and it's going to be a streaming RPC. Or in this case, we do specify an error that if the RPC fails, it's going to return a string, and that this one actually accepts a payload of an ID. So you have to send a payload to the RPC, and you might get a success of user or an error of string. So we're creating like a group of specifications for an RPC server or client, right? And then at some point we need to implement the handlers on the server side, right? So in this case, if we ignore the code that is, associated with an imaginary database, we need to take these user RPCs, and there's a method on it, the RPC group called toLayer, that allows you to pass an effect in to create implementations for each of these RPCs. And because we're calling toLayer on user RPCs, this is type safe. It knows that you have to implement each one of these things. It knows that user by ID is going to get ID as a parameter. And it knows that you have to return an effect that is either going to succeed with a user or fail with a string, right? Mm-hmm. And you'll get all of this information like in your editor as you're building this up. Yeah. And because these are effects, they can require services that then you can swap out in testing or at runtime. Like in this case, we're using a fake user repository here for the example, but you could imagine in production, this actually depends on like a database or something like that. So this pattern relies on having the spec and having implementations that are separated. And that's like by design. This way you can swap out the implementation that you use, whether you're testing, or even if you want to swap out the implementation at runtime based on like where you're running, for example.
Could I interject briefly?
Yeah.
I think one of the most, maybe you've touched on this, but one of the most powerful uses of this, the primary motivator, one of them maybe, of separating the definition, like the specification, as you mentioned, from the implementations, and just having that RPC .make, that's sort of the specification of the input, the output, the types, the schemas, etc. From its server implementation is because those aren't sort of coupled together any longer. You can take that spec and also derive a client from it. And that code can be in a shared directory where you specify the group, and you can, in the server code, add the handlers, and in the client code, you can just call it directly, and it'll call some server API or whatever. Whereas if you had to provide the handler implementation in line here underneath, say, stream or payload or whatever in each of these RPCs, Well, that code theoretically would only be able to run on the server, so you couldn't share that code across environments.
Right.
So
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 yeah,
I think
yeah,
one of the key pieces of this whole like setup is these requirements that show up when you actually attempt to use the user RPCs. So whether you create a server or you create a client out of user RPCs, you're going to end up with like some requirements that are derived from the spec, right? In this case, we can look at serving the API. We don't get types here, but like when you actually go to use, where is it? Where are user RPCs? Here, when you create an RPC server layer out of the user RPCs, this RPC layer is going to require these things, right? It's going to require these things, and then users live, which we then provide immediately here, satisfies those things. So here, like we immediately provide the things that we need. But the point is that like once you use the user RPCs somewhere, it's going to add requirements to your program on the handlers. And I think the thing that I'm driving at with this explanation is that at some point in your program, when you use the spec, you have to like fake add requirements that are associated with said handlers. With AI Toolkit, I'll actually open up the example with AI Toolkit. And I'll make this bigger. Just give me 1 second. Please. With AI Toolkit, it's a little bit different in that we create our tool. This is a spec for like an AI tool where we can give it a description. We can say what the tool, when you run the tool, what it's going to succeed with, what it's going to fail with, the parameters that the tool takes. And then, you can add tools to a toolkit. So you can create like a toolkit that knows what tools are in it. The way that we like associate the fact that you need X handlers for the tools in a program is when you actually go to use, we go to the part where we actually use the tools. When we pass a toolkit into a text generation method, we add those requirements into the requirements of that effect that we produce. And like this is the important part, because when generate text is called, that's where we attempt to like build the toolkit under the hood. Like, and when we build the toolkit, we like capture the current effect context, right? And we do a bunch of like, I'll use the word magic, but it's not really magic. We do a bunch of things under the hood to transform these tools into a toolkit with handlers so that you can like call the toolkit. The model can call the toolkit under the hood for you.
Yeah. So, so like imagine that all makes sense to me. Imagine if you wanted to yield your tools as a service.
You can do that with AI Toolkit. You can do that with AI.
Because I've tried like yielding it. Because there's a to layer, there's a to context, and then there's a of, and that's just the function identity.
No, you literally just yield the toolkit, and what that will do is it will
give
take
you access to like your AI tools that I can call like AI or dad jokes. Or get dad joke inside of a service. Because I tried to do that and I was failing. So I've been like using the of method and then creating an effect service.
What's the difference between a toolkit and an RPC group? They seem fundamentally the same. They expose a similar pattern, but the functionality and how you use them are quite different. Like the point is that I'm answering Sam's question while I pull up code examples, but the point is that the code, like the way that you produce an RPC group, the way you produce an AI toolkit should be similar, because the API is like if you've used an RPC group, you should know how to then use an AI toolkit. But what they actually do under the hood is quite different. An RPC group gets transformed into something that can be used by an HTTP router or by an RPC server, or like it's a different structure like under the hood that like it gets transformed to. Whereas an AI toolkit gets transformed into kind of like a bag of handlers that an LLM then has access to when it needs to call a tool. So fundamentally, like building a AI toolkit or building an RPC group look the same, and that's by design, but they have very different functionality. I was looking for an example where I use a tool kit. So if I change this program, I don't know why my editor's laggy right now. If I change this program to x equals yield dead joke tools. Actually, let's do exactly what you're saying. Class my tool kit service extends yield the bad joke tools.
Could you bump up the font size a bit?
Is that better? More?
Just a little more, yeah. Thank you.
So what you get back here is a toolkit with the handlers, so you can call x dot like handle a particular tool. And what's nice about this, and like, I'm not sure that this is a good pattern yet. Like Mike and I have been debating this for. Brother, how far was your plus key? We're not exactly sure if this is a good pattern yet or not, because for a variety of reasons, but I kind of like it being able to get access to the handler. The reason why this is kind of nice is because now my toolkit service.default, if you look at this, the requirements of the toolkit have now been lifted into the layer of the service. So like this layer now depends on the handler for dad joke. Like, so if I try to use my toolkit service somewhere, that program is eventually still going to need me to provide the dad joke tool handlers, right? But in this way, you can take an AI toolkit and use it in a service. And the reason why I exposed to this pattern is because, like, you could imagine that you might have like an, I don't know, AI helpers service, right? Where you want to just expose a bunch of methods like, I don't know, get a dad joke for kit, right? And, you know, there's a topic you want to pass in here, I don't know. And in here, you could actually have language model generation methods. So language model dot generate text. I'm not going to actually do all the things, but toolkit here would be X. And if I did this right, this should now only depend on language model, which, you know, you could, and again, you could satisfy this dependency in your service as well. You could have models that you provide here, right? But the point is that this method now does not depend on the handlers for this toolkit. The handlers for this toolkit have been lifted into the service, and you can now expose methods that don't care about the handlers in the service, instead, but still have access to be able to use the toolkit. In the same fashion, you could just have methods that use the handler if you wanted to, like, you know, get that joke. Like, you could do this if you want to. And the reason why this works is because if we go look at toolkit, is this the toolkit module? Yes. Toolkit extends effect. So it's an effectable type where the effect that it extends produces a with handler toolkit, like it's a toolkit with a handler, and it depends on the handlers for said tools. So, like, basically, you could literally if you wanted to expose similar functionality, you would just make your type into something that could also be like transformed into effect. And the way that this works is just by having this commit method here for the toolkit, which is the thing that like captures the current effect context and allows and builds up the cache of schemas for all the tools and exposes this handle method, which is the thing that then merges context. Where is it? Here. We propagate the context that we captured when we committed that toolkit. We propagate that and merge it with the context that like handle has access to. So like there's a bunch of stuff we're doing under the hood, but I think the API that's exposed is nice.
Yeah.
And that's how you could achieve something similar. If you wanted to be able to yield a contract kit inside a service, for example, and lift all those contract kit dependencies into the service, well, you could just make your type into an effect. And to do that in 3.0, to do that, you need to make it an effectable type or a type that extends effect. So you just need your type's prototype to have a commit method on it to satisfy that requirement. Or you can use like the effectable.class helper. I think there's one of those. Oops.
I haven't heard of this module.
I don't know what I just did. I just typed a bunch of things I didn't mean to.
That pretty much answers my question.
Okay, I don't know what I just did.
I was struggling with like lifting it into the effect service, but that makes sense. I was basically just using the .of method and then just providing the handlers to a service. But I noticed the of method doesn't do all the fancy payload and success.
Literally, the only purpose of in a toolkit, if we go back, the only purpose of here is as a thunk. It's literally a identity function that's type safe around the handlers.
Yeah.
So it doesn't do it doesn't capture context. It doesn't build the toolkit at all. It just produces handlers. So like it's useful, for example, in a situation where, let me go back over here. So let's imagine we're building up our dad joke tool handlers here. Sometimes when you've got when you use the 2-layer method and you don't immediately return an object, what I mean by that is you don't immediately return like this, because you can do this, and you see you get really nice like IntelliSense here.
Yeah.
When you use the effect version, sometimes you don't get really nice IntelliSense. So you can see I'm like, there's not nice IntelliSense here. To make it nice, you can just return dad joke tools.of.
Okay.
So like it's literally just a type safe identity method. So
that pretty much does it. I don't need to take up any more time. That sort of answered my question.
Cool.
Yeah.
I'm going to answer Roman's question too. That's interesting, but not too low level. Would be an abstraction for agent. AI SDKs define these agents with a bunch of tools and then run. The toolkit is the toolkit an equivalent of agent? No, I don't think so, Roman. The toolkit is just simply a way to have a nice spec first way of exposing a set of tools to a large language model. I think that the chat module, in effect, gets closer to what would be considered like an agent if you give it tools, because it tracks like the conversation history for you and everything. But we still don't have an agent-like abstraction in effect, and that's kind of on purpose because we haven't found something that we like yet. I kind of like the pattern that Mastra uses. Mastra.ai, I think, is the website. I like whoa, too bright. I kind of like the pattern where where is it? Where's the thing where they go through like steps? There's like an example. They've changed their docs quite a bit. So what I don't like, to be very clear about like what I'm never going to add to effect, is this type of thing.
Zoom up there. I'm trying to minority report it. Thank you.
Minority reported. What I don't like, and I don't think we'll ever add anything like this to effect, is this whole concept of steps and like on step finish and like basically everything that the AI SDK does to allow you to execute multiple steps automatically. I hate this API. I think it like takes all the control away from the end user. What I'd rather expose with effect is like an agent module where you, instead of like the steps being controlled internally, what I'd rather see is like in effect, if I can like exemplify what I eventually want to do, is to have something where you like, yield agent.make, and maybe you give it a toolkit or something, and then you could have, let's just, I don't know, step response yield agent.generate text, right? And you have full control over how these steps work, right? So every time you yield, it's like a different step that gets executed. And in this step response, you'd have access to things like, I don't know, obviously all the standard stuff we return and generate text, but then like you'd have access to step related information and things like that. But the point here is that like the control over the agent is explicit in this case, whereas with like this type of design with max steps, and I swear to God, I thought Mastra had a version of like their agent thingy where you could do this instead. But yeah, I think eventually that's the direction I'm going to head. But I think also Sebastian in the chat kind of summarized why I'm not doing this right now, which is that I think it's really premature for us in effect land, and I mean, I think in general too, but in effect land, to build too high level of an API over the top of what we already have, because even the AI packages are still evolving, right? Like a huge rewrite. Think of all the VC money you could attract. Yeah, Sam.
I think
just walk into their office and say the word AI. No, but seriously, like I think I want to try to get the APIs like right when we do expose some sort of agent level abstraction or something like that. And I just feel like right now you can get very close to what I'm talking about with the AI chat module, which is here. This also uses the persistence version of chat, but the concept is the same. Like with chat, you have the ability to create a chat object that you can call LLM methods on, and it persists the history for you. But if you use the persistence method, otherwise persistence is in memory. But the point being is like you can already get pretty close to this like agent level abstraction with the chat module. I'm not sure what having another layer on top of that really nets. So, Sebastian, I'm intentionally ignoring the fact that you mentioned that particular module.
Yeah, the Claude Code SDK is pretty decent as well. There might be something to go from there. I mean, they have you can add hooks to different lifecycle events for sort of granting permissions and whatnot, which can be useful to have that all built in case you are doing like a Claude Code style thing and want human in the loop responses. Well, yeah. Want to look at some code? Maybe this might be all messed up, but this could be fun.
Let's look at some code. Also,
Okay.
I hope I answered everybody's questions. Benjamin, thank you very much for joining us and asking your questions. Hopefully people got a little bit more out of that. We've talked about this pattern like in the last 3 or 4 office hours, so I know there's a lot of interest in it. But hopefully it's becoming more clear to folks like why we lean into this particular pattern.
Yeah, I love it. You guys done great work. Thank you.
Thank you, Benjamin.
Thanks, Benjamin.
Take care. Yes, and in fact, I think if my brain works correctly, this little presentation will once again reiterate that, except with a code example. So let's see what happens. Because yeah, the questions RJ brought up last time were interesting. Let me know if this is a good size
A little bigger,
for
Ken.
everyone. A little bigger? You're just trying to punish me.
Yeah, one tick more. I'm going to punish you. This is good.
3 more.
3 more. Zoom in.
This is good, you said?
I only want to see one character at a time, please.
It's too much. Could you change the font?
Could you change the font and the color scheme, please?
Could this not be a monospaced font? That's too regular. It's too uniform for my eyes.
Yeah, I agree with Sam also. We need relative line numbers, and we should randomize the theme every 10 seconds.
Yeah, but what about random line numbers, actually?
This is literally unwatchable.
Why did we invite Sam again? I don't remember.
Just for that, we should drag him into the video chat.
I wish you could just summon people, suck them in. So anyway, here we have some code. I'm going to talk about it. And Sam, please keep heckling me, and Maxwell, you can share his heckles on the stream. Wow.
Jesus.
Oh, ouch.
Now we're getting personal.
Yeah, I probably do need one. It's getting a little long on the sides. So, Sebastian, go away. Sebastian, you get a haircut.
He's allowed to heckle because he can actually spell the word heckle.
And pronounce it beautifully, mellifluously, royally. Okay, so I want to build an RPC API-like thing from scratch-ish. Of course, we're going to very much be relying on some copy-paste and some tabbing and our AI friends. So LLM compatriots. So there's some basic shit here we're just going to talk about off the bat. So we're going to make an abstraction, right? This HTTP API RPC group thing. It's an abstraction over something. What is it an abstraction over? Well, for HTTP, it is an HTTP server abstraction, which basically goes from some request to some effective response, right? That is basically that's almost literally what our HTTP server type is, with some hand waving. And then same thing with the effect RPC, kind of the same deal, except instead of decoding an HTTP sort of input and using headers, et cetera, and all of the RESTful conventions, it uses probably some binary protocol. I think you could swap the protocols, but still, really, it's just a function from some input to some output. Like, that's kind of what we're building here. Almost everything in programming is a function from some input to some output. So here we're going to build up a kind of server, but you don't want all the details of an HTTP server, so we're going to simplify it somewhat. We're going to maybe imagine some standard I/O process that takes in some strings. It'll be in some special format that this will have been pre-processed from, and then outputs some strings. So yeah, a very simple version of some server. And it can fail in a couple ways, in that, the input for a particular method, we're basically building like an RPC-like abstraction. So the input for a particular method could be malformed, or somebody could be calling a method that doesn't exist. So this is kind of an RPC abstraction once again. And so our server error is either one of these 3 error types, and a server is indeed a function from some input to an effect that'll return this little output type, or a server error. And here we have some example inputs that we want to work with. So we can call this list items method. We can get an item, and then we can also create an item. And these are going to be JSON strings that we're getting in here. So these are our RPC inputs, our RPC calls essentially. And then I'm going to make some domain types. So we have an item using schema.class, as I mentioned earlier. So we get all the fancy things for free. And then here's some example items. We can use item.make. That's fun. Isn't that fun? So yeah, another nice thing about having a schema is like, you just know it'll autocomplete if you hit Command P here in VS Code or whatever. It'll show you the types you need as you're typing it. And then we have some handlers. So list items, we're gonna use these later. These are like the implementations. It's gonna return some items, this example items list. Get item is going to look for the particular item in that example items list. Otherwise, it's just going to die and say it can't find the item. And finally, create item will just pretend that it created an item. It won't actually update anything. It doesn't matter. This is all a stub. And then we are going to have this server demonstration function that's going to list through the example inputs and call our server with each one and log the outputs. So we can sort of iterate on this. Now, I'm going to start by copy pasting something, sort of an initial implementation. Because one thing that I was thinking about last time when RJ was presenting the work there is that, and I think I mentioned this, is that when you're building an abstraction, a DSL, you probably have some high level idea of, oh man, it would be nice to call things and describe things in this way. But it's also really important that you understand the target of your DSL and what things are eventually going to transpile into. What is your target code? Because a DSL is really just some fancier, higher level version of code that's eventually going to generate some boring low level code. And it can be very helpful and grounding to start or have an idea of specifically what that low level code is going to look like. And then you can sort of let that guide and constrain the high level code, and they might both have to shift a little bit depending on certain constraints that you want. Maybe the low level code will be limited by the nice features of the API that you want at the high level, or you just have to account for certain aspects of the low level code, some invariants of the system you're targeting that it's going to have to make your API a little different or a little worse. So here is take care, Adam H, and we will see you in Videoland. So this would be the userland code, but pre-framework. So this is a server. Once again, that it's a function that goes from input to an effective output. So it's input, etc., to an effective output server error. And how is this? This is like not abstract at all. It's really verbose and annoying. So you basically are going to take the input, match on the method. So we're sort of hard coding this server that has this API of those three functions. What is it? List items, get item, and create item. So we're going to expect that we're called correctly. There's no type level constraints here. We're going to expect that our caller passed in an input that was one of our example inputs. So that if the item input.method is list items, we're going to then call our list items implementation, get the items, encode the result, and stringify it and return it as that output type. Same thing with the get item implementation. We're going to parse it. We're going to decode what have you, the input. We're going to parse the input as JSON, decoded it now because this one has an argument, then pass that argument into get item, and then re-encode its response. There's this decode, delegate, re-encode sort of pattern. We're making a little sandwich of encoding on either side of the core business logic. And same thing for create method and so on and so forth. And then at the end, we blow up with unknown method if we haven't yet caught something. And then we can run this server demonstration, run runtime, run main. I will run this, and we will see that, yes, if I run this a few times, there it is. So we have called list items, and the result was the JSON stringified ugly version of our items. So the server is working where we're parsing and returning a new item here, etc. So obviously this code is terrible in multiple ways, but it is a good place to start. Oh no. How do I close this? Where'd it go? DSL.
Looks like I'm about to roast all the Cloudflare fanboys, but this looks like a Cloudflare worker fetch entry point thingy. This looks like
I've never used that, but yes, this is not too alien of code, and it's everything, right? It's explicit. It's for all the the abstraction haters out there. This is what you love, right? It's clear as day what it does. No levels of indirection, very few levels of indirection. Well, except for the use of schema and whatnot. But yeah, no changes. It is perfect in a way. But why might you want to change it? Like if this works, fine, ship it. But the idea perhaps might be that, well, you spend your day job writing these sorts of things, time in and time out, and it's pretty error prone. There's no real insurance here that you're calling the methods correctly, that you're matching what was specified once. There's no single source of truth for your API, right? You have kind of these handlers that have an API, and you have the way that you're parsing it. But really, if you squint, there's kind of this structure, this schema structure, of the specification of your API, where you have these three methods that each require certain inputs and will generate certain outputs. So that's kind of what we want to move on towards. But we could do this as well in stages. So the first stage is this is all sort of co-located together. Like if you just wanted to be basically able to like there's something here rather that's how can we make this into sort of more of a generic library, right? You'd want users to at least be able to specify lists of handlers because this sort of matching over them is a little verbose. So let's get ourselves a version 2 here. Version 2. So now instead of having that if-else chain, we're going to specify a record of handlers. So a handler takes some input, which is going to be that JSON string, and it's going to have to return a JSON string. So basically input to output, except it doesn't have to bundle it up into that input and output shape because that was duplicated logic everywhere, and that can now be handled by our library code. So here's the userland divide, and it looks pretty similar. We for list items, we just call list items. We still have to re-encode everything. We still have to decode the JSON because we're just getting the JSON string, input string here. So that's still repeated everywhere. But we've made a little bit of progress, right? Framework code here, not much, but it is a start. So now make server can take a record of these handlers that we just decide elsewhere, and it'll return a server, which is a function from input to output effect. So this will at least look up based on the inputs method, the right handler. Otherwise, it will fail that it doesn't know that method, and then it will delegate to the result. And you'll notice that it can now destructure the params from the input, and it can package back up the output into the result. So it did something, not much. But this is like one step towards slowly trying to identify a pattern. But of course, there's a good deal of verbosity. Once again, every single handler needs to encode and decode manually to JSON. So a version 3 is now here. Now we have an RPC handler, which is going to have an input schema, an output schema, and then the handler, which is going to take the type specified by the input schema and return the type specified by the output schema. So now we're starting to have a little bit of that flavor of a single source of truth, where there's the schema somewhere that's going to be used to derive types elsewhere, like the handler. So these are going to be yoked together. If you change the schema, the handler should change as well. So, boom, comments. Cool. So here, our handler's record is very similar, except now we don't have to deal with any of that ugly parsing business. We basically just delegate to our handlers defined at the top, just the pure domain level handlers. So this goes from schema.void to schema.array. And by the way, point out, Maxwell, if I'm doing anything crazy with schema, because I think I might have some questions for you later on when we get to parsing this correctly. So yeah, this goes from void to array. This goes from get item input to item. I made a schema for the get item input shape, which is just the ID. So we have a schema for it. I could have also just done like a string or whatever type that is, and then create item does the same. And now make server does more. So here's our library boundaries. So library code. Our library is getting a little more useful. We're slowly trimming down on the user side of code and pushing more into our library. So now we get the method. We fail if we don't recognize the method. But now we also handle the parsing. So at the beginning, we match the RPC handler. And the RPC handler knows how to decode the input schema. So we decode that. And then we pass it along, the decoded input, into the RPC handler.
One thing we could improve with the decoding here, since you asked me to chime in,
yes.
The JSON parse. Where is it? Right there.
Yes, here. Yes.
You could lift this into, instead of doing the parsing here. I mean, this is fine. But you could also take your input schema and wrap it into a schema.parse JSON.
Okay. So JSON-ified input schema. Let's do this. So sort of like this.
And now if you hover JSON-ified input schema, you'll see that it's actually a schema. I mean, actually, we can actually just make this type nicer by wrapping the whole thing in schema.as schema. I think it's schema.as schema.
I like it.
This just
Okay,
makes the
and then
types nicer. You can see that it's
okay.
goes from string to any in this case, because the input schema is going to be inferred as any since you're specifying the RPC handler as any. But the point here is that like this will do the JSON parsing for you within the schema world. So you'll get like nicer schema
So
errors.
theoretically, I can just replace this input schema now with the JSONified input schema.
Yeah, and what is the type of you'll want the input type there. So input. Since
oh yes, input. Duh. Thank you. Okay, let's see. Let's see what happens. That looks much better.
And similarly, the output can be the same thing. Since encoding will go the opposite direction, instead of doing a JSON.stringify, you could just use the parse JSON wrap.
Parse.
Yeah.
Oh, sorry, JSONified input. Now, I'll need a JSONified output schema, right?
Correct. Yeah.
Okay, let me do that.
You're basically creating a schema that can be represented as JSON when it's encoded.
Okay, and then theoretically, I will just get the encoded output.
Yeah, because now the type of encoded output, since you're encoding, should be a string.
Yep. No, that the type's all checked, so that is correct. That is much better. Okay, I was hoping that is precisely the kind of tip you would give. I wasn't entirely sure how to do that, but that makes total sense. Let's see if it works. It might be weird because I have this void input. I think that may have given me trouble before, but we'll see what happens. Yeah, there is this kind of weird issue that I did get before, which is in version 3, where expected string, actual method, list, items, params. Oh, that's because I need to, I need to still extract the parameters here. Go away terminal. Because I'm giving it's any, right? But the params are the bit. Doesn't know how to abstract that. So maybe that was my fault from before. Okay, cool. It totally works. Amazing. That's great. That is very great indeed. That is much nicer to use schemas all the way down. Okay, I was hoping something built in would exist. So I've learned something. Okay, cool. So anyway, now we've made it even nicer. We've packaged up the parsing business and used schemas, and really the library code is almost as minimal as you'd want it. There's a few problems, of course. Actually, are there problems? Well, technically, this could be typed safer. I won't get into the reasons why this isn't exactly perfect. But yes, technically we could make input isn't totally pinned or pegged or constrained by the input schema because this is all in one argument list. It will, I believe, let one side widen the other. So if you have this be a schema of string, and this were a schema of, if this somehow took a number, which isn't true, but let's just make this take a number. This isn't a type error because it'll widen these to any. But there's ways of organizing this so that would properly constrain the types, which we will in the next step. Though now I have to redo that other stuff, which is totally fine. So yeah, a type safe handler is actually the next step here. And maybe I could just do it inline. So here, let me pull this over here and see what happens. So that's kind of the problem, as I just demonstrated. I can make this a type of string and this a type of number. And we can see that there's no type error here because basically what it does is it's going to say, okay, this is a string, this is a number. Well, we can unify these across this entire record. These are both the input types. So what type satisfies the concrete values I saw at both places?
I think in this particular case, the issue is actually that the value type of the record is an RPC handler of any.
Well, I think still, if we do it in a slightly different, so if we do something like this, nope, not like this, which is albeit a little verbose, and we'll take a look at this. If we do it like this, and I change this to make handler, and
yeah, this will work, but that's just because now we're constraining the types to be within make handler. But I think the reason why the types were as wide as possible before was because RPC handler any lets you pass any schema to any position in the record.
Yes. So, I mean, the other way around that I think would have been something like, let's see this. Const get item handler, right? So if I do this, and if I don't constrain the types, I can still change this to schema dot string, and this will work. And of course, because it's not really constrained by any type. If I gave it a manual type description here saying get item input item, then yes, I would indeed not be able to change this to schema.string or something because it knows that it has to be get item input. But if I want to fully infer just by like not have to give it a type, which is kind of ideal, and just have it inferred based on the arguments, you have to sort of make a constructor that does that. And there's a couple of ways of doing that, but one way would be this, where you could sort of extend these types for input and output schema.
And we can actually improve the generics in the first position a little bit better with so schema.schema any will make it a schema of literally anything, but we can make it a tiny bit better by doing schema.schema.any. Like there's an any helper in there, which is slightly more constrained than a schema of any. And then there's a schema.schema.all, which we can use for the error type. We can hang on one second.
Yeah, it seems might be a little messed up now.
Schema.type. Extend schema. What is the error that you're getting here?
It's a little confusing. It says that basically input schema is not assignable to type schema type input schema type input schema never.
And what is the type of RPC handler? Again, just scroll up a little bit. Schema.schema input, and then scroll down to make handler again.
I mean, this isn't so critical either. Maybe we can come back to this unless it's obvious. There's a few ways of getting this to type nicely. There's another way you can have a curried definition, and that will actually simplify things in some ways. But of course, then it becomes a curried definition, which you may or may not enjoy. But like if I don't like having to provide all this stuff, I can just kind of have I and O, and this can be a schema. Dot schema of I. This could be a schema dot schema of O, but then I will have to separate and make a second parameter list here. And actually make this a separate. Oh, because it's all like one type. What have I done? Because sometimes the types, giving the types in these places. Is this the actual implementation?
For those watching who are interested in 4.0 stuff, this type of like generic schema stuff gets so much easier in 4.0. It's wild.
Okay, that's very exciting.
Yeah. Every parameter in 4.0 becomes like contravariant, I think. Covariant, if I remember correctly. And I think that also the underlying types of schema has like 14 type parameters, but you can basically use can use this like top type in 4.0 to extend like these schemas, and it just makes like everything so much easier. I was porting some code the other day, and it's just so nice to work with for just to give somebody something to look forward to.
Yes, if wrangling types isn't your favorite pastime, which it is for me, actually, it's rather meditative. But this also works the same way. It turns out, I believe, if I'm wrong, I'm sort of transcribing knowledge from Scala into TypeScript, but this seemed to work out, which is that if you have multiple parameter lists, if you're currying a function, the generic types will be pinned down at the end of the parameter list. So once you sort of close this first parameter list, so if I made this, let's use make handler 2 for this one, and of course there are 2 parameter lists. Now ID at this point is known, like if I just delete all this and hit Command P, it knows that I need to have a handler of type ID is string, because the first parameter list has closed, so that generic input parameter has been hard-coded and set. But I can also do it this way as well, and similarly it will also know that it needs to be of type get item input. In fact, that's even sort of more specific than this other method. So anyway, multiple ways of doing things in TypeScript, many fancy ways. I think this is probably the most idiomatic way of doing it, even if it's a little more verbose in some cases. So I'm going to delete make handler too. But there are many ways to type a cat. Okay, so really this is the same exact thing, except, yeah, now we have this, it's a very minor type safety aspect, but yeah, there's some type safety here. And this would be totally fine as an API. You could just stop here, except what you then might want to do is break out as I mentioned earlier, break out a client and sort of have a shared specification that's just kind of the input and the output and maybe the name, and provide the handlers only in the server implementation later on. So let me grab another version from beneath. Boom. Okay. So version 5 still has the same RPC handler, which is sort of the concrete thing that will eventually be called, that our server knows how to parse. But then there's this RPC specification type that I made, which is just the interface. So for instance, it might just be name, list items, input schema, void, output schema, an array of items. Okay. And then we want ways of constructing these. And these are just to propagate sort of types nicely and to make a nicer API. As you see, these sort of like that function Maxwell showed off earlier that was kind of just like an identity function. This doesn't do it. There's not really any logic in here. It just takes your input types and puts them into the output type. But this will allow TypeScript to propagate specific types a little more nicely. Anywho, and then now we have a make server method here that's basically going to take these specifications and a record of handlers and sort of pair them up. So we're going to reconstitute our handlers. Before we just created our handlers directly with the schemas and their handler right beneath it. That's what we did in the last version up above somewhere. That's version 2. Where was it? Version 3. So yes, this was the version where we're defining the handlers directly with their implementations and schemas. But now that we want to break apart the specifications and the schemas, we need some way of unifying them. So we have the specifications and then we have the handlers. So we're going to go through each of our specifications and find each handler for each one, and then reconstruct a handler because the user doesn't define them. So we're going to sort of zip together the specs and just the handlers, not the user isn't going to redefine the name or anything. And then we can call version 3's make server now that we have these handlers. So this is what was defined manually by the user here. We pass it into make server manually, but now we just have this other step that will sort of wrap and decorate, reconstituting those handlers and then passing them along to version 3. So our user code now looks like defining a specification here, an AP, a group, basically, of these different calls. And we'll see that this is kind of propagating the types. So it knows it's a const array of these specific functions with these specific interfaces and these specific names. And then we're going to create the server by passing in the handlers later. And these are going to have to match the names of those functions there. However, they don't now because we didn't add that part. So this is the next challenge that you run into when you do want to cleave apart the specifications and their implementations. You have one less problem to solve if they are sort of always coupled and grouped together. But luckily, TypeScript can help us here. Let me just make sure this does indeed work. Hopefully it does. That would be cool. And it does. Yay. And then I have to slide this away because I don't know why the shortcut isn't working. So yeah, and you can also add additional methods here, and it's totally fine. This is completely untyped. If you look at the API here, it's going to basically be a list of, a record of handlers of any string to any input type. So very unsafe. Cool. So how do we make this better. So this one is probably the fanciest one type-wise. Let's go up to the top. So same handler specification, same handler shape. This is what eventually is going to get passed to our server and run that version 3 implementation of the server. And then we have our specs once again. And now we have some type level functions because these will come in handy. And I kind of broke them up into multiple layers here. Oh yeah, and there's no error schema at the moment. We could add that. It would behave very similarly to the result success schema, but just to simplify the code, there is no error type here. So when you have these types in TypeScript, and they look crazy like this, it's best to think of them as functions at the type level. They take some input type and they return some output type. Like all of these type aliases, they're called sometimes referred to as type aliases. I don't know what the proper name for them in TypeScript is, but I like to think of them as type functions. So extract input is a function that goes from an RPC spec, whose shape is name, input, output, and we just want to get the input value. And it's a bit verbose to type this, but there is a pattern. There are patterns you learn to get this to work correctly. And some of this isn't necessarily 100% required at this moment, but it's kind of a best practice, is a smart thing to do. So here, this is going to take a spec as its input, which is going to be an RPC spec. It only makes sense to call this with an RPC spec. If I'd remove this, you could call it with anything, but it would always return never, and it wouldn't really make any sense. So then we do this crazy thing, and it's kind of like a pattern matching syntax, but we're taking the spec, we're saying it fits this shape, and we're taking the second parameter, which is the input parameter. We're saying infer I, which creates, it sort of binds a variable. It's very much like a pattern matching syntax in the language like, well, Scala or Haskell or something. And then we can refer to that later on. And that's basically going to be whatever type was there. So this will have the behavior of taking that type and getting it out. And we can use this in other type functions, mostly in other type functions and function definitions. And then we do the same thing with extract output. It's the same pattern, except we infer the third type parameter and get that. And it's this crazy ternary, type level ternary syntax. But this is sort of one of the building blocks of TypeScript type systems. You'll see these type level ternaries all the time, which are super ugly. I wish they gave like a slightly nicer syntax. Why not a type level switch statement? Who knows? Type level pattern matching for real, but they don't. And so this is what we have. You eventually learn how to read it mostly. And so these are both extract input and extract output for RPC specs are both used in handler for. And so a handler for takes an RPC specification, which is of this type shape, and it returns a new type, which is a function from the input type of the RPC spec to an effect of the output type of the RPC spec. So it is the same definition here, which takes a spec, and then it returns a function type. And in order to type it, we simply delegate to the other function helpers. So sometimes you'll see these all inlined and your brain will explode. But it's nice I like to, if possible, extract helper function types just as you would extract normal code functions, and even doubly or triply so, because they're so absolutely horrific to read. And they'll drive you mad. So this is, for as much as you can call this readable, if you're not used to it, it's probably still not readable, but certainly more readable than if it would be if I replaced these with ternary statements. Can I inline these type aliases? I'm not sure if, even the LSP doesn't want to attempt to do that. Okay, so now we have these type level helpers. The most important one of which is that we can now go from an RPC spec type to the type of the handler that it wants. Okay. And so this is the same little make function as we had before. I believe we're using name extends string here to sort of keep this as a constant string type. So if you use the string literal hello, it becomes a type level literal hello, which is going to be absolutely key to getting this whole thing to work. It's kind of fancy. One example of this is name equals Kit. If I look at the type of name, it's going to say Kit. I'm not sure if that will always. So you can actually have the name Kit here, and Kit is not Kitty. Kit Langton is not Kit LinkedIn. No one's ever called me Kit LinkedIn, but I sometimes my brain insults me with that. It sounds suspiciously close to that. It is, of course, also a string, but Kit Langton is certainly a more precise string. Cool. And anyway, this is going to be very useful. And just one little example, return string is going to take a name and return a name. And if I do return string of Kit Langton, we'll see what the type is here. And it's a string. Notice what happened here. So name raw Kit. So Kit is Kit. It kept the specific typing here. But the second I call a function and pass it a string and return the string, it's string. Why is this? Well, because the input type was widened to string, and so that type will propagate. It's sort of this becomes a wider version of string, and then this returns that very same identifier, which is typed to string. So we've lost the specificity here. If you want to retain the specificity, well, we do what we did here, which is give it some my string extends string, and then we take a string, and now when we look at this, it is still the more specific literal type, which is pretty fancy.
And you also may want to put before the myString generic, there's a const modifier you can put on that.
That's even, I guess that would be even better. I wonder how, yeah, it didn't have that here. I didn't seem to matter in this case, but I know that's throwing on const is a good idea. Do you know what situation that would improve this or where it would fall apart without it?
I can't remember. I'll look while you're talking.
Okay, cool. Yeah, it's just a vague here. I'd like to know that. But yeah, definitely just throw const on things if you want these specific literal types to be maintained. But I'll comment that out for now. Okay, so that's what's going on here. That's why we have this helper function in the first place, because if you just define a raw object, well, you won't get type guidance, first of all, and you also will not necessarily propagate those very narrow types. Okay, and then a couple other helper methods, which are probably even crazier. These are still at the type level helper methods. So this one allows us to extract a spec with a name from an array of specs. So if you have a type level array of specs, which we will, which this will, something else will generate for us. So if you have a type level array of specs and you want to just get out a specific one, well, this is how it will work, spec by name. So you give it a type level array of specs, you give the name, and it will return the spec, the specific spec. I guess I could throw a const on here too. I'll throw a const everywhere now because I know I'm paranoid. Oh, no, I can't throw a const there for some reason.
Yeah, it can only be for like not generics and like types or interfaces.
Types, yeah.
For strings, it doesn't really matter that much. But if you want to maintain the constant nature of a different type, like, I don't know, an array or an object, it's basically the same as like saying as const on said type. I dropped a little article in the chat.
Okay, cool. I will check this out later. Perfect. So yeah, this is just a way of basically indexing into a type array, which is kind of crazy, and getting a type out. And this uses this built-in helper function called extract, which is, I can't get that to format correctly. Extract, which is built into TypeScript, which uses that extends trick again, the type level ternary statement. But basically, one of these specs will extend. It'll be a subtype of the type name to the specific type level string. So, if one of these specs is going to have in it name hello, and this is going to extend the object name hello. And if this were string, if I put string here instead of hello, well, they would all return. They would all facilitate that. So we wouldn't just pick out anything. That we would actually get back the same sort of type level array here. Yeah. So pretty crazy. Actually, it'll be a union type, but that's That's crazy. Okay, and we're almost done with this. The last helper, which is probably the craziest, but just look at the inputs and the outputs. It uses that handler form method. It uses spec by name, so it's a combination of everything. But basically, if you give this an array of spec types, you will get back the shape of the handler object you need to pass in, because it's going to, the key of this object is going to be the name, which is going to be that const literal type of each name propagated, so add and sub. And the right-hand side for that key, it's going to take the key, it's going to extract the spec type from this array based on the name. So the key for add is going to get back the add spec type, and then we're going to get a handler for it, which means take that spec type and it's a function from its input to an effect of its output. So that's crazy, but that's just some type level fun that we need to go from an array of specs to an object where the keys are the names and the outputs are the handlers. So now this is enough to constrain a properly type-checked handler object, which we didn't have before for a list of specifications. So now our make server is very similar to what it was before, except instead of taking a record of strings to handlers of anything, we take in a const. I could probably make this a const of specs. It seemingly wasn't necessary, but it probably would be in certain situations of an array of RPC specs. So this will get its very specific type, and then we're just going to use that directly there. So we're going to get an array of specs as specs, but then we now have enough type information that we can pass it along to our extract handlers function, which will of course require now here this type. The second argument is going to need to be and enforced to be by the TypeScript compiler an object of the anticipated, of the necessary shape as circumscribed by our spec array. So now, if we make the same array, and I did say as const here to propagate that type here, I could have also made, this is why maybe like an RPC group helper that did that for us would be nice, but here I have this very specific type, a type level array of type level string specs, etc. But now, if I forget to provide a handler, it will give me an awful error message, but nonetheless, it'll give me an error message. And if I mistype something, it will indeed give me an error message. It says, hey, list items does not exist in the type extract handlers list items. And it even doesn't. And I can't either add new methods as well. It has to be a record of that exact shape with these exact arguments as well. So I can't return, let's say, list items for the get item handler. It's all type safe. And there's a single source of truth at the type level, which is these, type level specs. I think I'm going to stop here. We could keep going to actually get to the sort of the point where you have a layer and whatnot. But really, all that's going to do is extend this one level further. Like this is the core of the type safety, and it's sort of just a matter of are you directly passing in this handler object, or is the server going to instead try to pluck this handler object essentially to some degree out of the context and force you to provide this implementation object later. And there will be another method called toLayer on some RPC group that will generate a layer of the right types to be consumed later. But I think I at least dealt with most of the underlying ideas. We can get to that some other time, but it's been a while, so we should probably stop in a moment unless there are any questions. Did that kind of make sense? I don't know. It's exciting to me. I feel like I understand a little more. But
no, that was great. I think one of the key things also that people should take away is that keeping the strict types for each RPC is important to preserve the type safety for a lot of these types of APIs. So like similarly in like the AI modules or the RPC modules, when you hover like the generic types of those and they like seem messy, it's because we need to preserve the type of the schemas. I missed something. Could you go over that again? We need to preserve the types of the schemas and the generics so that we have access to them in all the type helpers that we use to keep things safe. So like while the types might seem messy, it's like messy for a reason. Like there's an actual reason for it. So.
Yes. And I realized actually there is only one more step in my little pre-prepared example. So I'll very briefly, this will take 2 minutes, go over this, which is it's all the same for the version
Sam,
with layers.
Sam, pay attention, please. Pay attention, please, Sam.
Yes. I'm going over this again for you, Sam. Let's go to version 1 again. No, okay. So we have the RPC handlers. And this is sort of almost at the level of the core concrete implementation that could be hard coded, sort of. And then we have the specs, which allow us to dislocate the specifications from the handlers. And then we have these helper functions for dealing with things at the type level. For type safety, it does it exactly the same as before. Same with spec by name and extract handlers. But now we have this RPC group thing, which is going to basically just be constructed with a type level array of specs here. Those specs just like before, which was right here. So it's going to take this. Instead of doing this, you're going to say RPC group.make or whatever, and then pass in these RPCs, so just like it is in effect. And it will store these off. I don't think I need to do read only there. It'll store these off in this specs map. From its own name to the actual underlying spec. And then it will expose this a couple of methods. One is toLayer. So toLayer is going to take a function, an effectful function, or no, actually not a function. It'll take an effect that will need to return that handler's object. So instead of just taking the handler's object, now it can take an effect that returns the handler's object. And that effect can have its own requirements. So now you can depend on some downstream dependency, some database, whatever, some item service. And that will be propagated in this layer here. We probably shouldn't say never here. So I don't think that's fully type safe. Oops, that's something is missing in this implementation. I think there's a second step.
You can just add an E generic to before in toLayer, just add an E.
Oh, I meant for the output type shouldn't be never. Yeah, the error type we can propagate that along, but we definitely want the
output type in this case. Yeah, probably should be
something like
in most of our versions of this, we create like kind of it's almost like a fake
type wrapper.
Yeah, it's almost like a fake service. It's not fake. It's like something that actually exists in the context, but it's like a handler type, which is unique for every handler. So that when you like hover something that uses the RPC group or the AI toolkit or whatever, you see in the requirements that you need to satisfy X, Y, Z handler.
Yeah, right. It was just like handler string, etc. Handler.
Or for Sam, X, Y, Z. Sorry, Sam.
RPC example. Anyway, yeah, I won't look for this now. I have some example. Is it called a zebra instead of a zebra? In the UK, I'm reading my kid a lot of zoo books. Yes. Okay. Good.
It literally.
I don't know. That's true. That seems so absurd that I can't believe it, but it might be. It might be true. We live in a wild world.
No, I have to.
It can't be true. Get out of here, Sam.
It is unironically true.
Try. That must be the British
way to say zebra.
While we're looking up that, so barring that little issue there, what does this do? So it is
zebra.
Zebra?
It's not zebra. It's zebra.
Oh, okay. Well, okay. There's no D. I'm gonna call it I did, Sam. I said zebra, but zebra still sounds silly.
I gotta be honest, that's just not correct. Zebra, that's just not correct.
I'm sure Z must sound hilariously silly. It sounds like the undergarments from my IDE. Indeed. Anyway, so what does this do? toLayer, that my brain is swirling now. toLayer takes this function and it's going to basically turn it into a layer. Except we talked about how usually you have a context and you have a tag, but we built this in the other session where a context really is just a map from strings to some implementation. So if you unsafely make a context, you can just throw any map from strings to anything in there. So we are we're calling build, which is going to get us back that handler's object where the keys. Remember, this is an object where the keys are the names of the specifications and the and the right-hand side, the values are the handler functions. And we're going to stash into this context at some special key prefix, which I could probably further obscure, under the name of the spec, its handler. And we're going to throw that into a context and make a layer out of this. So now we're going to drop this in the top of the program. And of course, it should be made to be type safe. So this should provide some set of types that are also derived via a function, a type level function. Yeah. And then on the other side of things, let me pull this. We're going to be able to access a handler from the environment. So given a name of a particular handler, we are going to be able to get that handler out of the environment. So how does this work? Well, we're going to get the context, the current context. We're going to get the name of the spec. We're going to reconstitute that key, and then we're going to unsafely get the handler. And if we had the type safety, we would really never need to do this. I mean, maybe we'd still throw just because that would mean somebody's faking something.
Could die there.
This could probably be cleaner, but this is kind of the other side of things. This assumes that the context has been provided and it looks out of that map for us. And there's some ugliness here, which I'll. Oh, sorry.
Yeah, you can remove the outer effect.sync and the flatten.
Yeah. AI helped a little bit here to do this very quickly, and I'm blaming that, not myself. But yeah, that's there's some ugliness here as well. And of course, this should maybe return. I mean, this could be unsafe code. This would only be sort of library side code, the access handler. And once again, this is the same as before, except now there's a group that constructs an RPC group. And then the final bit is we make a server. We create an empty list of handlers. And now instead of iterating through, instead of just being past the handlers as that sort of extract handlers for situation that we had earlier and just sort of zipping them together, well, now we can anticipate that for this particular group, we have the handlers in the environment. So for each specification, we can get the handler for the specification and do basically the same thing, create an RPC handler, plucking the handler out of that unsafe map that has been provided above. Now, this should also have, as its R parameter, whatever union type of all the handler names are also derived. And if we do that for both sides, then it will actually be fully type safe. I forgot that one key bit. And now, we create our API, and then we say API to layer, and we can do anything we want here. So we could yield in this outer function, it's effect.succeed right now, but if I made this a sync, I could yield any other sort of dependencies, and they would get propagated at the layer level. So this is also type safe. It's literally the same type that's required as before, which is that handlers for a list of specifications. So this gets us a layer. We provide this at the top. We can use the server internally, and now we can actually run this program, and it succeeds all the same. Now, as I mentioned, it's not fully type safe because I didn't add any type constraints. So we can call this without providing the magical context, and it'll explode, being unable to find the list items type. But that would be the last thing to do. And maybe I could do it very quickly because it really isn't that. It could just be any type at this point, right? It doesn't even need to be a tag. I could just make sort of like a fancy
you can do it.
Type set for specs.
You can first you'll want just like a handler type, which you could just make handler which takes in a name.
Should this be an interface handler?
Yeah, an interface handler, name extends string. Okay. And then you want to propagate the name inside the handler. So like the interface has to be an object, put the name in there, and then also do a read-only underscore inside the handler. We're gonna make an underscore property. This is just a little trick to make the type unique.
Can't we just do out as well? Is that a whole other thing?
We're not gonna.
I'll do the underscore.
It's not for variance. Okay. And then colon unique symbol.
Colon unique symbol?
No, like underscore. Yeah, that's also fine. Literally, the colon property could be named anything. This is just to make the handler unique.
Oh, I see.
And we probably, yeah, exactly, Sam Rose. And then when you create the server, you'll need to take the spec and convert it into a union of handlers.
Yes. So given an array of specs, go to a. Why is this sad? It doesn't like. See, it doesn't even think that's a real word.
Yeah.
Must be read only. Okay.
No, the property has to be read only.
Oh, thank you. So this goes there, read only.
Yeah. Don't write me, bro.
Don't type me. Okay. So yes. To an array of so given
I could just
RPC spec union of handlers. So this would be handler A, handler B.
should work.
And will this work?
No, you
Example.
don't need the array.
Oh, it'll just be a union of these things.
Yeah, get rid of the array. No, that's fine. Leave the array there. We don't need the array, the type to be an array. Perfect.
Okay. Well, let's see. Let's get an example here of what this would be. And the way to do that would be now, instead of this would be a type level set for specs. So we can go down and see what the type is of our layer. Our layer is RPC spec. Well, it says type level. It did not really reduce it. Is that a problem, perhaps?
Yeah, so go to typeset for specs. Go back to the type itself.
Mm-hmm.
Where's it? Typeset for specs. Specs extends.
Oh no! It seems. It did this. Are you sure we don't need that? Would that not break the? No, that doesn't break it at all.
It doesn't need the array because we're not creating an array. We want a union. We want a union of each handler. I know what the problem is here.
Hey,
we need to create a mapped type.
Let's see if AI can do it.
It should be handler A, handler B. We could do this ourselves, but we just need
the beauty of
type.
Need a mapped type? Is this okay? Well, let's see what GPT-5 High does. Okay, I should have chosen faster.
Right. So in 4 to 5 hours, we'll get a response.
I know. Let's go do the new one. Let's see what you got, Cursor.
Yeah.
Perfect. Does this seem to be exactly what you wanted?
It's not using a maps type, but this is also fine.
It seems to work. So what's the deal here? So, okay, it did something. Specs number and first spec extends handler name.
You need to, you basically need to traverse the type here. The other way to do this would have been to create a maps type over the array and then index into it, which would have also created a union, but either way is fine. And then, you can...
Let's see if this worked down here in the two layers. So, yep, it's totally a layer of these individual unioned handlers, which means the last thing to do is to come up here and in access handler, or rather in make server, given some specs, this will now need to be requiring that same type, which means if I do remove this, we get a type error because it requires, well, it's a huge, ugly error here, but it requires these three handlers, which is provided by these things. So now it's type safe. Woo. Okay. That's kind of the pattern. It's kind of simple. The layer stuff isn't so important to it. There's some stuff to get type safety, but the core idea is that layers provide implementations downstream. It's basically providing some implicit map of values keyed by strings to a particular scope of your project. And there's some bidirectional type safety based on the layer of types, which is purely at typing time, type checking time, not at runtime. So at runtime, you're just smushing together a bunch of a big map downstream.
Sam, this is not app level code. This is library code for sure.
No, this is day one. This is if you don't get this, if this is weird,
if you don't get this, you're not going to make it.
Yeah, no. So the inspiration for this, I think, last session, a guy named RJ, I don't forget his full name, who I think works at Convex or whatever, is making an effect /convex DB integration, and he wanted to mimic the RPC API. So no, we do all this work generally at the library level to make things type safe, to make things nice to use, so that at the user level, it's really high level, and you simply write things like this, and it's all type safe, and you really can't mess up. And the LSP will be there to save you with nice type errors. But I find this very fun, and maybe this is office hours, so it's a little more advanced. Hopefully, just by looking at this stuff, you'll understand how it works under the hood a little better. Learn some type tricks. I'll learn some type tricks and schema tricks from Maxwell as I miss, whatever the rule of the internet is, that you just say something wrong and people will correct you. So I'm doing that here. Yeah.
You ever just say something wrong on Twitter to get people to come correct you? And it's like the alternative to generative AI. Generative Twitter. You say something totally wrong on Twitter, and you let all the graybeards come out and like fix your stuff for you, and then you move on with your day.
Just every day, yeah. I got to hook that up into my IDE every time I get a type check, instead of like send to AI, like tweet this, in some reverse form.
And it's free. There's no tokens involved. You just say something on Twitter and it's
Well, that was really fun. It's been 2 hours, so I think we should probably, I don't know, we all have lives. We should take care of our families. What are you doing, people? But really fun hanging out. Come back again next week. Maybe we'll do the same time again, because Sam stayed the whole 2 hours. So until Sam stops showing up, maybe next time he'll, get a little used to the water. He'll call in a few times, and then he'll be the host. He'll replace me, and then I can go on a break. All right, same time. Okay, same time next week then, everybody. Sorry if you had questions that we missed them. Definitely post them in the Discord. And I do think the best way to make efficient use is like if you could prepare a little reproducer ahead of time, and then we can go through it. Like I think that might work the best. I mean, we'll still iterate and figure out what's going on, but we'll figure out what works best. But I think that seems to be nice, is to like have a little reproducer. And then if you also want to call in, we can talk about it and look at the code. It'll be easier to get more questions in, I think, that way. Thank you for showing, everybody. Mwah. And see you next time. Peace.
Later, folks.